Hello guys. I'm just gonna check that my streaming is working good and that my audio is working good. So welcome. This is my new channel. This is my channel for just technology, AI, programming business. Previously I was doing around 29 chapters on the other channel, which is from my music channel, but this is gonna be the first one in this new channel. So from now on everything is gonna be streamed in here. I'm just gonna check my audio is good. And now, just a small recap. We have been studying an AI associate path for developers in DataCamp. And now what we are doing is we are already on the 9th course. The other streams of the other courses were done in the other channel, but anyway, I put it in collaborator with this channel so you can watch it on both sides. But from now on, it's just gonna be on this new channel called Luisenrique.builds. And here in this building applications with pinecone, we're almost at the end. We just missed like one video and three exercises. So let's jump right into it. Let's see.
Welcome back. In this video, we'll implement a question answering chatbot using Pinecone and OpenAI. Crucial to this is a process called Retrieval Augmented Generation, or RAG. It's a system architecture designed to improve question answering models by providing them with additional information. In RAG, a user query is embedded and used to retrieve the most relevant documents from the database. Then, these documents are added to the model's prompt so that the model has extra context to inform its response. We start by importing the necessary libraries, initialize the Pinecone and OpenAI clients, and connect to our index. We'll work with a dataset containing YouTube transcripts. It includes columns such as text ID, channel ID, video title, text, and more. Later, we'll save all this information as metadata. We'll insert this dataset in batch sizes of 100 and split the dataset using NumPy's array split function. With each batch, we'll extract the metadata using a list comprehension. This creates a metadata dictionary for each row in the batch, assigning the row values to dictionary keys. We also extract the article text to embed and create unique IDs for each row using the UUID4 function. Next, we create a request to OpenAI to embed these texts, extracting the raw embeddings from the response. Finally, we zip together the IDs, vectors, and metadatas and upsert them to the YouTube RAG dataset namespace. Now that our documents are ingested, let's implement a function to
Here it does the upsert, zips.
Upsert them to the YouTube RAG dataset namespace. Now that our documents are ingested, let's implement a function to retrieve relevant documents from a Pinecone index based on a query. It uses the same OpenAI embeddings function to encode the user query, extracting the embeddings from the API response. The query embeddings are used to query our YouTube.
So here we create embedding on the query response, we get the embedding, then we send the query, the top K, the namespace, and they include metadata. Okay.
RAG dataset namespace to retrieve the most relevant documents. For each retrieved document, we extract the text and source metadata, appending them to the retrieved docs and sources lists respectively. Finally, it returns the lists of retrieved documents and their corresponding sources. Here's the function in action, retrieving the transcripts based on the user's query, along with the video's title and URL.
Nice. Nice. So it's super nice because it's embedding the query, making the request to the vector database, and then it's retrieving the documents.
Now,
I mean, normally in the way that you wouldn't do without any of the embedding, you will need to make some sort of like search with regex and stuff like that, but you don't capture the semantic meaning. So in this case, we are trying to find the closest to the semantic meaning of our request with what we saved in our database.
User's query, along with the video's title and URL. Now that we have the top K documents, we'll construct a prompt with context builder function to create a contextual prompt for our model. It glues together an instruction in prompt start, the most relevant documents are joined together with the join.
So first we're querying the If you're recording the document and the source,
title, will
and then
model.
we append the docs, and it says prompt star answer the question based on the context below. Context the question, we pass the context, which are all of the documents. Nice. And then we got the
It
end,
glues
which
together
is the question.
an instruction in prompt start. The most
So in both cases, what we're doing is we're passing the query anyway to the vector database, so we get the most similar with regarding the topics that they're asking us, and then we pass the retrieve documents with the system prompt and the prompt of the question.
relevant documents, which are joined together with the join method, and the user query in prompt end. Here's prompt with context builder in action. The final prompt includes the retrieved document followed by the user's query. This prompt will be used to generate the model response. Finally, let's create a question answering function. It takes a prompt string, document sources, and uses the OpenAI chat completion endpoint. We'll define two prompts, a system prompt, setting the model's behavior, and a user prompt, which will be the output from our prompt with context builder function. The function returns the final answer with document sources. Here's the function in action.
Right here, I get the system prompt, and then we
final
call the OpenAI
with documents
API with the completions. We send the system prompt, we send the request of the user, the temperature 0, so it's like super deterministic. Then in the answer, we get the
sources. Here's the function in action. Note that there are three sources, as we retrieve the top three documents or transcript segments based on the user's query.
Okay, some of the part that I didn't get here is
the function returns the final answer with document sources.
And then here we're getting I mean we're putting the answer plus the sources that we got from the previous in here. Okay.
Here's the function in action. Note that there are three sources, as we retrieve the top three documents or transcript segments based on the user's query. Putting it all together, here's how all the functions work together from user query to the final generated answer. Time to give this a go.
That's cool. That's amazing, because we're only not having the information, but also the references to where we got this from. Okay, and now we're going to hide our data camp, because now we're gonna do everything in Visual Studio. So give me 1 second, because I'm going to show my Visual Studio. Now it's there, and now we are in the exercise number 22, which is abstracting transcripts from YouTube. Actually, this might be pretty useful for the tutorial that I want to make, because I want to compile all of this course. I want to make a new UI that I can teach you step by step how it works, all of it. And then I want to make a chatbot for them, and also like probably search, which might need like some rack too. All right, so first we're going to put this downloaded dataset into here. So I'm gonna open this in the file explorer. Here. Then I see that we need to do this in here. So give me 1 second, because in the 22 there's something wrong here. This is the one that I should. So here we're in the 22. Now in the 22 we need to delete this. Then we need to do this copy. In here. And then we need to do this read, and now we're going to get we're gonna read the CSV, but in this time it's gonna be from the YouTube. We are going to make the array split from the, okay, in this case it's called YouTube data frame. Splitting is batching. For each batch I'm gonna insert the text ID, which is going to be, okay, the rows are ID, they are the same actually, text, title, the URL is URL, and the published is, well, it's a date, so it's published. Then I'm gonna convert this batch text okay, so I get in the IDs, and then in the input I am putting here the okay, I'm putting here the texts. Then in here I'm doing the client embeddings create. I'm getting the response, I'm getting the embedding, here the embeds, here I zip this, the namespace is going to be called, in this case, YouTube rack dataset, and then it should be here from this index, that absurd, yeah, and then I observe this, and then I say that's pretty much. I'm just gonna copy all of this, and I'm gonna put it into data camp. Because there I also need to do I also need to paste the key. It said that it's 401, and I guess that if I okay, maybe it's different from the total vector count is 200. Okay. Okay, in data can be passed, but what I'm gonna do is I'm going to complete all of this into Visual Studio. So now for the retrieval, which is the next part, building a retrieval function. So in our case, in the 22, we need to do this. We need to query response so here we're gonna create the client embeddings create. The input is gonna be the query, and the model is gonna be the same model as here. So here I'm gonna get from the query is gonna be the embedding, and here when I make the top K, in the top K we want to have, well, the top K that we define here. In the case of the namespace, we should put the namespace that we're getting from here, and we should include the metadata so it returns us also the metadata. Here we have the retrieve docs and we have the sources append. We got the, so here we already got the docs, and we're gonna return to just the retrieve docs and the sources. So yeah, so basically here we can already copy all of this on the retrieve, and then in here we're gonna run this on data camp. Now we're gonna submit this. Because here in the embed model, I need to also put the model that is coming, so it's fully enclosed. So now, yes. Okay, and now in the final step, what we need to do is make this query from here. So basically our query can be defined in here, so we can pass the query to here, so we don't need to define this anymore. Now here we have the differences. Now we retrieve, but in the retrieve we already did this, so we don't need to do this. But in our case, in the data camp, we should put here the query. The top K should be 3. The namespace is YouTube rack dataset. So I'm gonna also create variables here. That's gonna be like this, and I'm also gonna do the embed model, which is going to be the YouTube, the text embeddings model. So then here we got this, here we got this, then the retrieve the top K, I'm gonna put also create here a variable called top K. It's equals to 3, and then we do the top K here. Then we don't need this. Here we have this function defined here. So prompt with context builder is going to get the query and the docs, and it's gonna return you a prompt with the context. And then in the question answering, we should do the same, the chat completions. It should be client chat completions that create, and in the model I should specify the, well, in this case the model is going to be GPT-4o mini. And in there, which is the system, we're gonna do the system prompt. So it was already defined there. And in the content, I should put the prompt with context. Then that should be it. So then if we run this into prompt with context, I'm gonna now complete this into data camp. So it's gonna be something like this, and I'm gonna copy this client chats completions create, and then from here I'm also gonna paste the pinecone keys. Then on my data camp is all ready, also my Visual Studio is all ready. So I guess I'm gonna run first here. And I'm running now in the data camp to see how it goes. So yeah, I think it worked good. I see the response. This is just in case it's gonna be 22, 23, and 24. And so I need to specify the model from here. So in this case, this is gonna be, because I hard coded in data camp, but I should put like the model which is defined in the environment variable. And this is the chat model. Give me 1 second. Yeah. I think no, it's good, but I don't know what's going on in this data cam. Maybe I'll reload the page in a second. Oh, wait, I need to do. Did you specify the recommend messages? Some other for messages. I did specify good the argument. Okay, I'm gonna take a hint. Okay, I'm just gonna show the answer then. It's all exactly the same. And no, it's all exactly the same. I don't know why I did it. I don't know why did it failed. Even if we do a copy paste from here from messages. Okay, apparently. Okay, because here I'm passing the prompt with context. Alright, so because here's a function inside, so here I need to pass the prompt. Okay, and now it should be correct. Okay, so now I understand. In this question answering, here I'm passing the prompt because I forgot that this is a function here and this here. So that's why it was failing. I'm gonna run this. I'm gonna run this 22, 23, 24 in Python to see what is the response that I got from there. I should do cd, and this is embeddings, Python 22. This is not, this is applications with Python, with pinecone. And here, let's see what are the errors that we got. MP is not defined. So I need to get import the here, import numpy as np. Just gonna from here, and let's run it again. I think we have the same problem as this batch iter rows. I think in the previous one is because I'm having another version and the data camp is using an older version. So in here, what we were doing was we need to do this for it was this, and this is the YouTube df, and I'm getting the batch from here, and now it should be not as good. And also I think in the embeds we should do only this because it was already coming in a format that I could just pass it like this. So let's run it again, see what we got. Yeah, that's so nice. So it is giving us the answer that we wanted, which is basically the response and the sources. That's amazing, guys. That is really nice. So now we have a proper pipeline to retrieve similar things that we want from our question. From there we pass the similar things that we want, we pass it to our OpenAI API, and then from that augmented information we can generate a proper answer. So this is perfect. Now let's go back to the pinecone because it's the goodbye of the course. It's the last one. It's the last one, so let's watch this.
Congratulations on completing the course. It's time to wrap up and reflect on all that you've learned. In Chapter 1, you dived into the fundamentals of pinecone, understanding its core capabilities and benefits. You created your first serverless index, connected to it, and began ingesting vectors, including their metadata. In Chapter 2, you got hands-on with different pinecone vector manipulation methods, including fetching and querying. You really took it up a gear and used vector metadata to filter your queries and maintained your data integrity by updating and deleting outdated vectors. Finally, in Chapter 3, you explored advanced concepts and real-world applications of pinecone. From performance tuning and multi-tenancy to semantic search and building question-answering systems, you gained practical insights into harnessing the full potential of pinecone for AI applications. You're now equipped to begin tackling AI projects with confidence. Pinecone and vector databases in general are a small but very important piece of a larger whole. As you saw in the final chapter, vector databases are often combined with other systems to enable some awesome applications. Pinecone integrates seamlessly with various platforms like Amazon Bedrock and SageMaker, Hugging Face, and LangChain. Take some time to explore these integrations and discover how Pinecone can enhance your workflows and enable new AI applications. Remember, learning is a continuous process, and DataCamp offers a wealth of resources to support your growth. Once again, congratulations on completing the course, best of luck, and happy learning.
That's good, guys. So now we finish this course.
Congratulations on completing the course. It's time to wrap up and reflect on all that you've learned. In chapter
Now we finish this. Now we need to go back to the learn part, because now we have only 2 courses remaining in here, and in here you can see that we only have now the 8 and 9 courses: software engineering principles in Python and developing LM applications with LangChain. So that's pretty much it for today, guys. I need to do some other work. Thank you very much, and it's been a pleasure. And this was the third, and the video live stream number 30 in our channel. So see you in a while.